All right, so f of x is 3x plus 1. So we are now finding g of 3x plus 1. Does that make sense to you? F of x is 3x plus 1. So that means we're going to take the the 3x plus 1 and plug it in to the g function. So we're plugging f into g. So that will be 3x plus 1 squared minus 4. Or 9x squared plus 6x plus 1 minus 4. Or 9x squared plus 6x minus 3. Now, anybody have a question about that? Is that all right? Did you, my arithmetic okay? Do not then do the quadratic formula or something with this. You're not solving that. That isn't an equation set equal to 0. That is simply what you get when you do g of f. Okay? All right, what's the domain of this guy? It says find the domain. What's the domain of that composition? All real numbers. And we don't have a problem with that because what was the domain of the function we started with? All real numbers? If there had been restrictions on this domain, it would follow through the whole problem. But since we have no restrictions on anything, it's perfectly fine that our result has no restrictions. Okay, let's do another one, and then we'll move on. You want to go ahead and just try these on your own? I think you know how to do them. And then we'll compare answers. Use function P and function Q now. And see what you can come up with. Please don't take mine as gospel. I may have made a mistake up here. For sure. So let's talk about the ones that need. point. Were you able to get an answer for the first one?
Could you not take out an I?
You could. I may not have stressed this the other day. When we're dealing with functions, we're keeping it real. So when we talk about domain, we're not including anything that would produce an imaginary number. So I didn't probably make a big enough deal about that. So when we're dealing with function operations, we want to be real number oriented. So could I absolutely come up with an expression with an imaginary number? I could. But we don't do that with functions. Okay? These are things we hope to be able to graph. And while you can't graph in the complex plane, we don't want to, we want to be real. Alright, so is that okay with everybody? First one didn't work? Alright, I got this for the second one. Do I have any concurrence with that? Anybody want to argue about it? Think it might be wrong? Does it seem okay? Q of x was negative x squared. So remember what that means then is whatever this is, it's plugged in for all of the x's. So it looks like this. Is that okay? Now, what's the domain of this right here? Does this have any domain issues? Are there any issues with the domain in the whole problem? Andy's shaking his head, and I don't know if it's, I don't know what he's doing back there, but you're shaking your head, and you're right. Yes, you are. You shook your head. Yeah. And so, which is fine, because the answer is no, there aren't any domain issues. So your domain here is the set of all real numbers. No problem at all. Now, I couldn't get this one to work either. Now, here's why. Well, first of all, make sure I did it right. Q of x, and then I took that and plugged it into P, and I got this. Does that look okay? Now, this would not necessarily be a problem, because this could be positive, right? But when I put that squared on there, doesn't that guarantee this will be a negative number? And therefore, I can't do it? Right? So, wait a minute, so what's the domain of this one?
I put everything to infinity because on negative x squared.
You said negative infinity to infinity?
Yeah.
Okay, now let's talk about that for a second. So here's what I want you to do, Aiden. I want you to pick a number. Any number. Any number. 2. All right, if we did this, so what would Q of 2 be? Q of 2, wouldn't Q of 2 be negative 4? And then we're going to find P of negative 4, which will be 2 root negative 4. Are we doing that? Are we doing I's? No, we want it to be real. So clearly our domain isn't all numbers because 2 doesn't work. Alana?
So how come when you square, like before, why wouldn't it be just positive 4? If it's like,
Where are we at?
like at the beginning. Wouldn't it be like if you?
Oh, here you mean?
Yeah.
Okay, remember, there's a difference between this and this. Here, we square the number and then make it negative. Here, we square the whole number, including the negative. So when I put 2 in here, I square the 2 and then make it negative. So that's how I got negative 4. Is that I'm answering your question? Okay. Okay. So, what's your thought on this? What's the domain here? Kids, what does this tell you? Is this problem possible?
No.
And if it's not possible, then what's its domain? Empty set. There isn't a domain. No x value is going to make that work. It's impossible. You did it in general. This is the general work right here. It doesn't work for any x. Aiden proved it, that it didn't work for 2, because he tried it, and it didn't work. But it wouldn't work for 5, or root 17, or anything. It doesn't work. All right. So here we have no domain. This is no domain. No x values. All right, I got negative 4x for this one. Did I do my math right, or do I have a mistake in there somewhere?
That's what I got.
Did you
I
got
got that.
All right, now, if you just found negative 4x lying out in the parking lot, what would its domain be? I know numbers. But where'd that negative 4x come from? It came from this, right? Didn't we have to start with that? So think about it in terms of a mapping, guys. This says you're going to do function p first, and then you're going to plug it into q, right? To get here, which is the composition, don't you have to have the right numbers here? And what would the right numbers be? 0 to infinity? This problem, this composition, is only doable if you can get the ball started with that function. And you can't do that function unless x is bigger than or equal to 0. So that means the domain of the answer is also bigger than or equal to 0. Remember that the restrictions of the original follow you through. Lane?
So it's gonna always be of what would be inside the bracket since those restrictions that are gonna follow through, not of like Q.
Well, here's the deal. What you end up plugging into Q is what is actually, I mean, that's coming out of the composition, so it's probably okay. It's a good idea to keep your eye on it, but you're not gonna be able to do this step right here. You're not gonna be able to get to the composition if Q's not working. So usually the one that gives us trouble is the first function, but obviously we are using the second one too, so kind of keep an eye on that one. Yeah. Good question. Anybody have a question about that? We have this conversation when we are building compositions. We don't have this conversation when we just have a random function out there. Okay, super. Number 5. Whoa. Let's see. Okay. So now we are building compositions and describing the domain. Of a couple of more complex functions, it looks like. All right, so do I have any volunteers to come up? Maybe one person does that one, and another person can do the other one in middle order. You can come up with a friend if you don't want to come up by yourself. Anybody want to do that? Thank you, Lane. Anybody else? Which one are you doing? Doesn't matter. Who's gonna volunteer to do the second one? Seth, you're dying to come up. I see it right now. Come on. You got it. And you can choose one of your partners what should everybody else be doing right now? Doing it on their own.
Yeah.
The only reason you would ever FOIL it is if it were part of a fraction and maybe something you cancel out or something, but if there's no simplifying, then I would do it. You're right, you can't, well, you can't simplify that at all, no, so you're right, yeah.
I think that's what it's because that takes down the
Did you say it looks right, is that what you said?
It looks right to me.
Okay.
So I think it's
Well,
right.
that's all right, looking right's good,
It feels right.
feels right. Sometimes you just gotta go with your gut.
I'm pretty sure, I'm like 98% confident.
All right, so it's a little tougher problem. So here, let's look at their answers first, and then we'll talk about the domain, because sometimes that domain stuff can get a little complicated.
Oh, I didn't.
This is what Lane got as his answer.
Correct, but no,
That's all right. Did anybody else get that?
Yeah.
Everybody's okay with that? Okay, so the composition looks good. Seth got this right here as his composition. Is that what you got? Do we need to talk about that? Is everybody okay with that? Okay, so now let's talk about the domain. Now, let's look at, Lane's problem. In Lane's problem, to build this composition, we have to start with function g. And what do we know about the domain of g? Doesn't 1 minus x squared have to be bigger than or equal to 0? Now, this is an inequality. What you cannot do, even though sometimes we try, what we cannot do is add the x squared over and then do this. That does not work in inequalities. That is a property of equations, all right? So what I would suggest maybe that you do instead, this is how we approach these problems in chapter P, I might factor this. And then on my number line, there's going to be 2 dots. They're going to be nice closed-in dots. And where are they going to be? 1 and -1, right? And then I need to figure out, I know I'm going to shade somewhere, but I'm not sure where. So I might pick a number like 0. If I put 0 into this, is that true? If I put a 0 in there, does that make that true? Yes. Now you can go ahead and try these, but remember they alternate, so there's no sense in trying it, but you can if you want. Do the same thing, put in -2 and +2. So your domain is everything between -1 and 1. Now what that means is, if you are going to graph Lane's composition, which by the way, you should be able to do that. If you are going to graph this would be an upside down parabola, moved up 1. But instead of graphing, so it should look like this, instead of graphing the whole thing, you can only graph the part between -1 and 1, right? So we have to cut it off and only graph that part. Oh, wait, would those be zeros? Yeah. That would be a picture of Lane's function.
You get the greater than sign.
This?
Yeah.
Well, remember, when you take the square root of something, it has to be positive. So positive means greater than or equal to 0. So that's where it came from.
So why do you do the greater than or equal to 0 and that's like an equal sign?
Because whatever is under the radical has to be positive. It doesn't have to equal 0.
Okay.
It can equal 0, but it can also be something positive. Okay? All right, now let's look at sets. What do you think the domain of this is? Seth, are you saying it's nothing?
I think so.
Let's talk about that for a minute. Because if you're telling me it's nothing, then that means there is no number at all that I can plug in and make that work.
So something like super small in between 0 and 1.
Sure, sure. How about between -1 and 1? Because won't the negative get squared out? Like if you use 0.1, won't you get the same thing as -0.1? So what would you say your domain is?
-1, comma 1.
Yeah. The domain here is exactly the same thing. It's exactly the same thing. Now the shape's gonna be a little bit different, the slope's gonna be a little bit different, but the domain's the same.
So why did we do just like the x squared? Why did we just square that? Why did we square that?
Okay, I'm not sure I understand your question, but the f, this says function f, and that's x squared. So I'm finding g of x squared, which means I go to my g function, and every time I see an x, I put in x squared. So it's 1 minus x squared squared. You put x squared right here. All right. Now, thank you, man. Thank you for doing that. Coming up and doing that. All right, let's look at number 6. Now we're doing backwards composition. This is actually called decomposition. You are decomposing the functions. You have, in problem A function that does 2 things. It multiplies by 2 and it subtracts 5. Hi, Daddy. Oh, Daddy loves you. Oh. I love you. You go see with Daddy tonight? You want to say hi to the kids? Say hi to the kids? No. What is it? No. You can take one home, okay? Remy's got some paper at home. You can take one home. Want to take a pretty color? All right, let's take a pretty color. All right. I love you, my angel. We'll see, okay? Remy's got to do some compositions. Okay?
Oh, thank you.
You want to take it home? Okay. And then, all right, and then here's baby Sophia. She came out that way. Okay. What a pleasant surprise. Bye, honey. I will come home, I promise, okay? I'll come home. Remy gets the babysitter. Okay. Now, we are sorry about that interruption. I promise it isn't usually this crazy. They never come to school. This is the first time. All right. So here we go. Our function is 2x minus 5. So if you put a number into this, it's going to times by 2 and subtract 5 in that order, right? So you need to build 2 functions that will make that happen. So what are the 2 little functions that you're going to put together to get this big one? Okay? Any thoughts on that? It's easy. What's the first thing you need to happen? Multiply by 2. So our first function is going to multiply by 2. Now, what is our second function going to do? It's going to take that answer and do what? Subtract 5. Now, sometimes kids will say 2x minus 5. That's wrong. Remember, you take this and plug it into here, right? So when I plug 2x into here, I'll have 2x minus 5, which is my answer. Another thing kids might do wrong is put them in the wrong order. If it says f of g, then you've got to do g first. Okay, let's try the next one. That's not so hard. What's going on in b? Oh, 3 things are happening in b. You are cubing, you're adding 1, and you are squaring. These are grading nightmares because there's more than one way to do it. Okay? So who's got an idea? What might we let g of x be our first function? Hank?
X squared.
X squared? Okay, and then what would you let your second function be?
Oh, wait, sorry, I think I might have done that.
Yeah, I think we want maybe our last one to be x squared, and our, if you're gonna let your last one be x squared, then your first one has to be x cubed plus 1.
Yeah.
Because that's what you gotta plug in here to square. Now, somebody else might say, I'm gonna let my first one be x cubed. Then what does the second one have to do?
X plus 1 squared.
It has to add that and then square it. All right, try the last one on your own. Remember, cosine is one of your BFFs, so it works just like all the rest of them. Also, I switched the order here, it looks like, so we're starting with function f. David, what do you think? What's that?
I did f of x is equal to root x,
Beautiful.
and then g of x is equal to cos x.
Does that look okay to everybody?
Yes.
Easy. All right, number 7. Implicit functions. Now here's the deal. If I asked you to graph this on your calculator, first of all, it wouldn't do it. Because what shape is that? That's a circle. And what's wrong with a circle? It is not a function. And your calculator is a function machine, especially when you have a set in function mode. Could we, in order to put in my calculator, don't I have to have y equals? Isn't that the way it goes in? Could I get y by itself in this equation?
Yeah.
Yep, I sure could. I would have to subtract the x squared. And I can't put a y squared in, so I'm gonna have to square root. Do you agree with that?
Yeah.
Okay, let's graph that on our calculator. Just use a Zoom standard regular window. And tell me what's the matter with it.
What? It didn't do the bottom half.
What? It didn't do the bottom half. Can somebody explain that to me? Did it give you the top half of the circle? Let me tell you another little hint. Does your thing look a little less than circular?
Yes.
Does it look a little elliptical?
Yes.
Okay, if you want to, go to Zoom, and the 5th option is square. That will square your screen. So if you're a little concerned that maybe your shape isn't as good as you need it to be, you can always zoom square. Now let's talk about why that is. See this calculator you paid $100 for? What shape is that right there? A rectangle. And so when you set your window to -10 to 10, so what that means is You have negative 10 on the x-axis, negative 10 on the y-axis. What automatically happens, doesn't the picture get distorted this way? Because the screen isn't square. So if you want to see a more accurate picture, hit zoom square, and that'll be not for it. But we still have a problem. We only have the top half of the circle, David.
How come when you root it, it's not 5 minus x?
Okay. Would you agree, David, that 3 squared plus 4 squared is 5 squared? Is that true?
Yeah.
Okay, let's take the square root of both sides. Is 3 plus 4 equal to 5?
No.
It doesn't work. When you square root the entire quantity, not each piece. Okay? We never, ever, ever square root each piece. Okay, guys, I committed a pretty significant error back here. When I took the square root of both sides, what did I forget? You gotta have a plus or minus. So, you're gonna not just put in the positive square root, but you're gonna put in negative, oops. You're gonna put in negative the square root of 25 minus x squared. Now, when you graph, did it bring in the bottom half?
Mine connected.
Huh? Mine don't connect either. I know there's a reason for that. I don't know what it is. I've long since quit worrying about it. But Google it or something, you can figure it out. Here's the deal. These two equations that you typed into your calculator, these are called the implicit functions. Your job was to find the implicit functions, and you just did. You can't graph the whole circle at once. So what do? You solve the equation for y so that you get the top half, which is a function, and the bottom half, which is a function. So your calculator will graph those, and then you can end up with a shape that's not a function. Those are called the implicit functions. They are the little functions implied in the big function. All right, let's try the next one. Oh, this one will challenge you a bit, maybe. What do we have to do to find implicit functions? First of all, why by itself? Let me back up a second. You knew this was a circle. You may not know what this looks like. It has an absolute value in it, so you would expect that it would look like what shape? A V. But this time, there's a Y inside the absolute value, which means you're going to have a V, but yes, David, it's a sideways V. This is not going to be a function. So I got to split it apart into its two implied pieces. All right, here we go. Would you agree that the absolute value of y equals x minus 1? Does that rearrangement look okay? What am I going to do with that?
You have to make two equations, one as a negative y, one as a y.
So y equals x minus 1 would be one of my implicit functions, and negative y equals x minus 1, or y equals negative x plus 1 is my other implicit function.
Would it be a negative x? Because you put the x over. Oh, never mind.
I went this way. Now, I have one more comment. Let's go ahead and graph this. Tell me what shape you get.
Sideways V.
Well, you didn't get a sideways V. You got an X, didn't you? Which makes sense. These are both lines, right? So you graph these lines, and they intersect each other. And now you got the X. Here's the part that you've got to remember. It always comes down to domain. When you went from here to here, Lane, when you said, okay, I'm just going to drop the absolute value, what assumption were you making about y? positive. Because if you take the absolute value of a positive number, it's just itself. But if you take the absolute value of a negative number, then it's its opposite. Does that make sense? So when you look at your x, you cannot look at the whole line. For this part of the line, you can only look at the part where y is positive. So that will be the top half. For this one, you have to look at the bottom half. So we end up, this is your first equation, and this is your second equation. We have to ignore all of this. Are you following that, you guys? It's a little bit complicated. Well, it really isn't. You just have to be thinking about it. Okay? And it helps that you know this is a v, so you know there's something wrong with the x. This part can't be included because it's not part of the domain. Implicit functions, here they are. For that problem, these are the implicit functions, and you'll want to include the domain part too with that, in order for your graph to be right. All right, we have one more problem to do, and then we're going to look at some other things that aren't functions and talk about how to graph them in even yet a different way. All right, let's read this problem about a snowball. Jake stores a small You figure this out? This sounds kind of like a math-related problem. Speaking of which, the t-shirts are designed. We'll be starting to sign up next week. What are your thoughts on this? The original diameter is 4 inches. And we're losing 1 cubic inch every 40 days. So our diameter will be 4 minus 1 times the number of 40-day increments we have, the number of 40-day, I'll say increments. Well, how many 40-day increments do we have? 9, because every 40 days, 360 days. Wait a minute, what's wrong with that? Yeah, something's wrong with my setup. What is it, Hank?
Shouldn't you be doing formula for the volume of the sphere, since it's like a snowball? And you're subtracting cubic inch?
Yes, you're right, because it says lose about 1 cubic inch of volume. So, all right, let's come back. Instead of 4 here, what should I put? This is 1 cubic inch of volume. So basically I'm losing 9 cubic inches. How much volume did I start with?
4 inches.
Well, I started with a 4-inch diameter. So how much volume is that? What's the volume of a sphere? 4/3 pi r cubed. Right? You should remember that somewhere back there in the recesses of our mind. Okay, so my radius is 4, and 4 cubed is 64. so what is that, 256 thirds pi?
Your diameter.
Oh, thank you.
Thirty-two.
Yep. So this should be 2 cubed. So 32 pi over 3? Yep, big mistake, that was better. Alright, so now what's this? This is my original volume minus how much I'm losing. Would you agree with that? Alright, so I think I'm gonna go ahead and get a number for that. 32 pi divided by 3 minus 9. Did you get a volume of like approximately 24 and a half?
Yeah.
Alright, I know there's more than that. I'll keep that on my calculator. Okay, so does that answer the question?
No.
No, because what was the question?
What's their diameter?
What's the diameter now?
So you gotta run it.
So now I have to undo what I just did. So now I have this number right here, and it's on my calculator, so I don't need to retype it in, I've got it. But approximately 24.5 equals 4/3 pi r cubed, and that's my new radius. Does that make sense to you? So now I'm gonna take this number that I have, and I'm gonna times it by 3 and divide it by 4. Does that make sense to you? And now the number I have is pi r cubed, so I'll divide it by pi. And now the number I have is just r cubed. So I need to cube root it. And when you cube root it, you can either just raise it to the 1/3 power, because that's cube rooting, or you can go back into your math menu and choose the option that says cube root. For me, it's 4. And cube root that answer, and it's 1.8. So the answer is about 1.8 inches. So the cube root, you can either raise it to the 1/3 power, or you can cube root
It's
it.
asking for the diameter.
Oh my gosh, okay.
So then you multiply.
So
by
then
two.
it's 3.6 inches, thank you. So the new diameter is 3.6. Is that okay with everybody? That problem's in this section, I have a feeling, and I didn't write your book, so I don't know, but I think it's in this section because we were bouncing back and forth between diameter, radius, and volume. So it was like a composition, plugging radius into volume and then plugging volume in to get radius. I think that's why it was there. All right, quickly, let's at least talk about this new vocabulary. Oh, by the way, that included that section. So that homework, which is 1.4, will be due on Tuesday. Yep. Emergency? Okay, if it's an emergency, go. If it's not an emergency, stay, because we're gonna talk about a new vocabulary word. All right, top of page 17, parametric equations. Defining x and y in terms of a third variable t. The best example I can think of for this that might make sense to you is, if we have, here's our coordinate plane, and we have a car moving in the coordinate plane. So here he is moving in the coordinate plane. That's a car moving along. This is a point, x comma y. Would you agree with that? That is the point where the car is at, let's say, type t equals 2. That's where he is at 2 minutes. This point is a different x comma y, and that represents where he is maybe at t equals 3. So somebody's location physical location, horizontal and vertical location, can be identified or defined in terms of the time that it took you to get there. When you do that, when you define x and y in terms of a third variable, which is very often t but not always, that third variable is called a parameter. And the equations that you come up with are called parametric equations. So here's a simple example. All right, Sam, you still awake? Yep, we're gonna finish this problem and then I'll shut up, I promise, okay? We'll finish it. These are parametric equations. See how x and y are defined in terms of t. So the first part says, find all the points determined by t equals, okay, so I'm just gonna say, these are gonna be my t values, and this is gonna be my ordered pairs. So -2, -1, 0, 1, and 2. Here we go. What is my ordered pair if t is -2? -1, 0. Check my arithmetic, is that right? T is -2. And then -1 would be 0, -1. 0 would be 1, 0. 1 would be 2, 3. And 2 would be 3. And 2, so that'd be 8. Double check, I'm kind of making mistakes today, so I want to make sure we're right. Everybody okay with that? That's easy. So we could graph these points, we could plot those points and see what it looks like. Eliminate the parameter. In other words, find an algebraic relationship between x and y. So what they're saying in kind of a fancy way there is, let's make one equation. Instead of having two, let's put them together and make one. Any thoughts on how we can do that? David?
Substitution.
Exactly. What am I going to substitute?
T.
Exactly. So I'm going to solve this for t, because this one's much easier than this one to solve. So I'll solve this for t, and then plug it in. So y equals x minus 1 squared plus 2 times x minus 1. Does that look okay to everybody? And now clean it up. And my answer is x squared minus 1. So in other words, these two parametric equations describe this parabola. So if I plotted these points, I should get this parabola. Now, we're almost out of time. We're going to graph that by hand. I want to get to this in the calculator. I'm going to graph this on the calculator. Once you go to mode, up here in the top, mode, and notice that down there in one of the lines, right now you have function highlighted, but what's right next to function? Parametric. So we're going to go down, we're going to highlight parametric, and then we're going to press y equals. And you notice that this time, instead of saying just y equals, what does it say? X equals and y equals. So we are now going to put in these two parametric equations. So x equals t, and t is your variable button. If when you press what you used to press to get x, now it'll bring up t, because you're in parametric mode. So t, oh wait a minute, that's the wrong one. T plus 1 and t squared plus 2t. Hit graph. our window too, so go to window. Now you have a whole bunch more stuff in window, right? Okay, so we need to adjust this. What do you want T to be? What kind of numbers can we plug in for T? Can't we plug in anything we want?
Yeah.
So why don't we just say negative 10 to 10? T step, let's just leave that alone. We're gonna talk about what that means. And let's do just negative 10 to 10 for X and negative 10 to 10 for Y. Let's just start with that. Now when you hit graph, did it give you a nice little parabola you were expecting?
Yeah.
No? Okay, so what did yours look like? Let's talk about it right now. Okay, so she got some funky thing. Now we know what it's supposed to look like. Hopefully, yours looks like that. She got something absolutely crazy over here. It looks something like that. Because her step, where it says T step, her step was set inappropriately. Now listen to me. When your calculator is building a table of values, the step is how far apart your T's are. We had my step set in my calculator, I think it was set at 1. So it's just like this chart right here. She had hers set at like 7. So what was happening was, instead of plotting a point every 1 step, she was only plotting a point every 7 steps. And so when it connected, you didn't have enough points to get a smooth curve. In general, the smaller the step, the better the picture, because you're going to plot more points. But here's the problem. If you set your step too small, it takes forever, because then the calculator is plotting billions of points. So you kind of want to find that balance. Okay? When you get a jaggedy picture, fix your steps. All right, I'm going to shut up here, but one more quick comment. Remember, your calculator is now set in parametric mode. So when you try to graph something normally, it's not going to work. You need to change it back to function mode. Okay? All right, we'll continue this discussion next time.